So now we're going to consider a graphical display called a dot plot, which is just a frequency graph where you use stacked dots instead of bars. So let's look at an example. We want to construct a dot plot for the data on family income in thousands of dollars. So here's the data. And then I've already constructed the dot plot here, but let me tell you how I constructed it. So I looked at my data here and I scanned for the largest and smallest values. So I see a 28 in there and another 28. So it looks like 28 is the lowest value. And then the highest value looks like is that 87. So then I laid down my horizontal scale here. Did a low of 30 and a high going up almost to 90. And then for each data value, you just put a dot on the graph. So I've got a 28 here, so you get that first dot. 56, so that's a dot here. 87, that's this dot here. 42, that's this one here. You just keep going. And then when you get a repeated value, like here we have another 28, then you stack two dots high at 28. So 28 had a frequency of 2, and then it looks like 55 and 56. Yeah, 55 and 56 had frequencies of 2. Everything else had a frequency of 1. Notice this data is pretty spread out. We've got lots of gaps in the data. And it's really hard to tell a shape of a distribution with this smaller set of data. But dot plots can be useful here for same types of things that stem and leaf plots are, and box and whisker plots. You can see the distribution of the data. You can spot possible outliers. You can judge the approximate center of the data. Like here, it looks like the center of the data is around 55. And you can see how spread out the data is. We'll finish up this section with the law of large numbers and its relationship to the mean. So the law of large numbers says this: if you take bigger and bigger samples of the population, then the sample mean x bar will get closer and closer to the population mean mu. So, and that kind of makes sense because eventually if you take a sample big enough that you take up the whole population, then the sample mean and the population mean will be the same. And then a sampling distribution is just a relative frequency distribution for the means of many samples of the same size. So sampling distribution for samples of size 10, you would take a whole bunch of samples of size 10 and look at the means of those samples and put them on a frequency distribution, relative frequency distribution. That's what the sampling distribution is. So remember, frequency distributions are tables. So a sampling distribution is a table. It's showing how the means of samples are distributed. We'll talk more about sampling distributions later, but just wanted to introduce that topic here.